Okay, one of the very important skills for graphing is to be able to come up with a linear equation from points as opposed to having to do it always from the graph. And because sometimes the graph can be problematic. And sometimes we just need the equation and we need to do some things with the equation. So it's better if we can efficiently come up with the equation from 2 points. So sometimes these 2 points are not all that friendly either. They're decimals and they're not whole numbers. So sometimes it's problematic to get gradients and y-intercepts from the graph. So basically, we've got 2 points. We know that we have the gradient here, and we know they have the y-intercept is here. So we have to find those 2 things, and we can do them algebraically because we have learned that we can get the gradient from 2 points by using this little formula here, which is just the change in y over the change in x, which is basically rise and run. But we just do it in a formula way. So we know that this is x, and this is y, this is x, and this is y. So we're just going to stuff in the y's and stuff in the x's into this formula. So the y is, for the first point is 4, minus the y for the second point, which is 10.5. And then x minus x, which is 20.5 minus 30. And we just do that math. So we just do 4 minus 10.5, which is negative 6.5. And then the next one, which is negative 9. 20.5 minus 30 is a negative 9.5. Now that's a very ugly gradient. But don't be scared by that. First of all, when you have a negative in the top and the bottom, that just turns this positive. Because when you divide 2 negative numbers, you get a positive. So this is a positive gradient, right? And I mean, we can check this if we go into Desmos. We can just have a look at those 2 points. And we know that those 2 points, if I put a line through them, it's going to be a positive gradient, right? So we might want to take those 2 gradients and, come on, you can do it, and turn them into, see what they come up with as if I just divide them. 6.5 divided by 9.5, just to see if that's a little bit friendlier and a little bit easier to deal with. It's not really great because it comes into a very long decimal number, but let's just say I'm going to round it. It's not great, but let's just say I'm going to round it. Okay, so approximately 0.7 or 0.6842 is the gradient. Now, it could be money, so it could make sense a little bit to the context. We don't know what the gradient is at this point. But what we know is, we know that the gradient is basically 6.5 over 9.5 x plus c. Or we could round it off and use it as a decimal, 0.684 x plus c. Depending on the context. Now we need to find c, so we know that what we can do is we can take one of these points, doesn't matter which one, and we can substitute it in for c into the equation so that we can find c. So 10.5. I'm going to substitute that point. Here is x, here's y. So y becomes 10.5 is equal to, I don't know if you want to use the fraction or the decimal. I'm just going to use the decimal. It's going to be a little off, but it'll be close, and I'm going to substitute in the x plus c. Now, 0.684, if I leave it as 0.684, and I multiply that by 30, it's going to give me approximately 20.52. So 10.5 is equal to 20.52 plus c. And so c is just going to be 10.5 minus 20.52, which is negative 10.02. All right, so now we've got a gradient that is y is equal to, not very friendly, 9.5 x, and then it's minus 10.02. It's an ugly equation, but sometimes you're going to get ugly numbers, and you need to understand that we could still get a gradient, we could still interpret that gradient, and then we have a y-intercept and so on. And so that's kind of how we're going to be able to get an equation from